we're going to explain how to automatically close idle connections in PostgreSQL. PostgreSQL, like many database systems, allows multiple connections simultaneously. However, leaving connections open indefinitely consumes resources and can impact performance. Fortunately, PostgreSQL provides mechanisms to automatically terminate these idle connections. We'll explore two primary methods, using the idle in transaction session timeout parameter and configuring the statement timeout parameter. 1. Using idle in transaction session timeout. This setting defines how long an idle session, a connection that's not actively executing commands, can remain open before starting a transaction. Once this time elapses, PostgreSQL automatically closes the connection. To adjust this, you'll need to modify the PostgreSQL.conf file, typically located in the PostgreSQL data directory. Find the idle in transactions session timeout parameter and set it to the desired number of seconds. For example, idle in transaction session timeout equals 300 will close idle connections after 5 minutes, 300 seconds. Remember to restart the PostgreSQL service after making this change for the alteration to take effect. This method is particularly effective for connections that remain open but haven't yet started any transactions. 2. Using statement timeout. This parameter sets a time limit for individual SQL statements. If a statement runs longer than the specified time, PostgreSQL will terminate it, effectively closing the associated connection. This is beneficial for long-running queries or queries that might get stuck. Similar to the previous parameter, you'll modify the PostgreSQL.conf file, locate the statement timeout parameter, and set it to your desired timeout value in milliseconds. For example, statement timeout equals 300,000 will terminate statements after 5 minutes, 300,000 milliseconds. Again, restart the PostgreSQL service to apply the changes. While this doesn't directly target idle connections, it indirectly manages them by preventing long-running queries from hogging resources and implicitly closing connections when those queries time out. 3. Checking and monitoring. After implementing these changes, it's crucial to monitor their effectiveness. PostgreSQL provides tools and logs to check the number of active and idle connections. Regularly reviewing these logs will help you fine-tune the timeout values to strike a balance between resource efficiency and application functionality. You don't want to set timeouts too aggressively, as this might interrupt legitimate long-running processes. It's essential to carefully consider your application's needs and the typical duration of your queries when choosing these values. 4. Other considerations. Keep in mind that application-level connection pooling can also play a role. Connection pooling mechanisms often have their own timeout settings, so you might need to coordinate these settings with the database-level timeouts to ensure consistent behavior. Also, consider the potential impact on users if connections are unexpectedly closed due to timeouts. Appropriate error handling in your applications is essential to gracefully handle such situations.